Okay, thanks everybody for coming. Clifton Simmons is one of our star earth science majors. He's been doing research with me for 2 or 3 years. He's been out to all of the mammoth sites. He's done work with me up in the upper Rio Grande Valley on glacial stuff, on fluvial stuff, on soils research. And this is one of the studies that he's been working on with me, geoarchaeological study of Fossil Creek wetlands. This one's up in Fort Collins, Colorado.
Yeah, so like I said, or like Jared said, we were in the Fossil Creek wetlands in Fort Collins, Colorado, and it's actually located within the city limits nowadays. So there's heavy development, and there's actually a large railroad that runs through the site as well. So understanding future potential archaeological sites is very important, and that's where geoarchaeology comes into play. So first, I kind of want to go over what geoarchaeology is. It's a relatively new field of science. It merges archaeology and geomorphology together. It studies landforms, how they evolve over time, and then most importantly, in my field, we study the soil horizons and how soil develops over time, and that'll give us climatic and also any kind of anthropological information as well. So a soil horizon, in this image here, you'll notice there are lines that have been dug out. We usually use trowels to do this. Each barrier in between the lines is what we designate as a soil horizon. A soil horizon is a stacked layer of different structural, different colors, different materials in themselves. And a geoarchaeologist would dig into, usually a cut bank is preferable, but pits like this are dug as well to get down and study what the soil actually looks like, what the development is, and then use that information to help archaeologists in the future to determine whether or not this area has any kind of archaeological potential. One thing we really look for are buried horizons. A buried horizon is a surface horizon, so up here, what is usually delineated as a horizon. These are characterized with a dark color, usually a high organic material. And if a dark band were to be discovered lower in the profile, that is a good indication of a buried horizon. These buried horizons represent a time period of stability that allows for vegetation growth, it allows for occupation of humans, and this is what you look for to inform archaeologists. This is where potentially archaeologically rich areas would be. So for this project, this is a relatively new one. I've participated with Dr. Beaton in South Fork for a continuing research project out there. This is the first time we went out here in Fort Collins. We worked alongside the Colorado State University Archaeological Field School. They had a Paleolithic Indian site there. This is an image of one of their dig sites actually, in their process of digging. They have what is a really well-defined dark black band here that they consider to be what is called an anthrosol, which really isn't a solid term yet, but is a term used in the field to describe any kind of soils that have been manipulated or transformed by human occupation. So at this site there are several fire pits and hearths that are discovered, as well as lithics. So it's a very well-known human-occupied site. So our determination was to go out into the field and other areas, look at profiles of the soil there, and determine whether these areas would contain archaeologically significant sites as well, to help with the development of housing. And when I show you the maps, you'll see how close the housing development are starting to creep in to the archaeological site. So we're helping out with any kind of future disturbances of the site to alert the archaeologists that this area here could have some potential. So this is the location we're at, US map, and then a little closer, this green star here is Fort Collins, and this red asterisk is the dig site, and then this is a more blown up area. One of the most important preliminary steps of geoarchaeology is to map the area of landforms to understand what it is that you're working with. In geoarchaeology, Terraces are one of the most important landforms that we work with. They provide a wonderful area to actually dig into to get a good perception of what the climate was, the water table, anything like that. So here we have Fossil Creek that runs through here. So this is on the archaeological site is on what we call an old floodplain. So the floodplain when the channel was higher, and since that floodplain was the modern, it has cut down into steps, what look like steps on a profile, and each terrace is a different time period of downcut deposition and then downcut again. This area is also located on alluvial fan material, both old and new, representing a change in not only direction of flow of the area, but also depositional and aggradational rates. And they're all delineated here on your legend. And then it's mostly T1, T2 is what we delineate terraces, and the lower being the T1 and then the T2 being higher, although different studies can be different ways depending on who the researcher is and how they perceive it. So the methodology and the approach to this research, a lot of this is done in the field. So the field analysis, like I said, we do landform mapping, the horizon description, so we get down and we actually figure out what horizons are present, and then after each horizon is designated, then we begin to do structure, texture, color, gravel percentage, and then we'll gather samples for lab analysis as well from each designated horizon. If there's any charcoal, which is what we look for carbon-14 samples, it's a good indicator of age. That's what we primarily use for dating, although there's other techniques, OSL and isotope dating, but those are really expensive, and carbon-14 is pretty standard and trusted. And then the lab analysis that I ran here at Adams State, I ran organic percentage and also sand, silt, and clay percentage to understand, identify buried horizons that we identified in the field to confirm that they were actually, in fact, possibly buried horizons. And the sand, silt, clay percentage is used to understand the development of the soil as well and build an understanding of how old the soil is and what kind of conditions the soil is developing in. This is a sample of a test pit that we dug out in Fossil Creek. The hole in the middle here we dug because we ran into a large pocket of sand. So we wanted to test to see how low the sand went, if there's any buried soils underneath that. There was not. The sand is what we call a parent material. So the soil builds off of this sand material into the soil as it goes, because soil builds up. So it'll start with a parent material, usually bedrock or really heavily weathered rock is around here in Colorado. But this, since it's on a floodplain and it's next to a river that has sand, so the sand is what the soil develops out of, and then it builds up to what we have on the surface. Again, this is a GIS reference map showing the different dig sites we had. That runs right through here is the railroad, and the railroad's been there for quite some time. So it's important to understand the disturbance of the railroad construction and what that would have with anthropological dig sites in the future. If anything were to be located along this site, can it be trusted to be found in situ, or would it be moved elsewhere due to the construction of the railroad itself? Here we see the housing construction, which in the first map that I showed, the development hadn't even reached out here yet, but it's already knocking right on the door of it. So the important part of our research is to, if we find anything that would say or suggest that these people that they're already digging up would be found in this area or anywhere else over here, that the production of these houses would be slowed or stopped to prevent any kind of disruption of the site. And again, this is the general overview of the area. This is the area that we did studies in. In May, I do plan on taking younger students with me and Dr. Beaton out into this area and to conduct more scientific research out here to help build the understanding of this area. This is a Birkeland soil sheet. This is the staple of what geoarchaeologists use in the field. So what you have is your depths, your horizon designations, and then you have everything else, all your characteristics that you train for, or you test for in the field. This is really important to understanding exactly what it is you're looking at and organizing your thoughts on what the soil is that you're looking at, what kind of structure it is. And by structure, what we mean is how the soil itself clumps together. If you were to put your trowel into the side of the wall face and you pull out a chunk of soil, how does that soil break apart? Or is it angular? Is it subangular? Does it hold together well? Also with texture and structure, what you do is you get a little bit of it wet and you roll it around in your hand. You feel the grains to see if it's sandy, if it's silty, if it has a lot of clay content in it. And it'll change. It'll be more gritty with sand and more smooth and velvety with more silt and clay. And then with a number 10 sieve, you can find and determine the gravel percentage of the soil itself by sifting it through the sifter. Any kind of gravel that's left over, you compare it to the bottom of the sifter and you can come up with a rough estimate of percentage. So the lab analysis that I ran, I did organic testing, which you just use a muffle furnace, and then I ran a hydrometer test, which is what you use to find the sand, silt, and clay percentage of the soil itself. And the hydrometer test is usually about an 8-hour minimum test. And the organic material is a relatively quick one. So what we have in the field results, these are the designations of the different horizons that we have. So in our first site here, we have 11 total horizon designations. The large capital first letters is the designation of the actual soil profile itself. Anything that comes after there is a description. So an A horizon, like I said, is usually characterized with a dark band. A B horizon usually has a little more clay content to it, has a little more structure as the clay is alluviated out and into the B horizon. The little K that we have here is what is called calcium carbonate, a calcic soil. So you have little white powder buildup residue on rocks or in the soil itself. The little b is with this one here. So the little b is what we designate as a buried soil. A buried soil, like I said, is what you want to find in a geoarchaeological research. It helps to designate specific areas for more efficient archaeological research itself. The combination of the AB and the BK1 here is the barrier between soil horizons is never very clear. It's usually blended or what we call welded. So a particular soil may have a certain characteristic for a very short amount of time or a very short space and then start blending into the next characteristic. So they'll usually be designated with multiple soil profile designations. The C here is what we call the parent material, or what the soil starts off with in order to develop and become a more fertile soil. So what we have here is we have a lot of calcium carbonate, which is pretty routine to find around a water source like that. Calcium carbonate precipitates out of the water whenever the evaporation goes. So as the flood table rises and flooding occurs, once that is over and the evaporation takes part, then you can find calcium carbonate precipitate out. Also a good indicator of climatic conditions with calcium carbonate is the depth at which calcium carbonate is usually found, is a good indicator of the annual precipitation rate. Here on the third site and fourth site here, we have what are called AP zones, and the little p stands for plowed. So this is an area that was under agricultural disturbances, which is an important feature to understand. Any kind of disturbance that the area could go under is important for the anthropologist to understand whether the artifacts they're finding is in situ or not. And so we had 4 sites that we designated, and I only have 3 here because one of them was right across the bank from this first one and had identical profile. The other ones had different profiles. insinuating that there was a different developmental conditions, whether they were being used for farmland more, and this area just wasn't, or if they were just destroyed by the railroad construction as well. So this is the organic compound percentage. What you want to find here is these areas that we have just designated as buried soils. If you find a spike in the organic percentage after you burn off the organic material inside the soil, you're looking at a buried soil, a buried horizon, because the organic material, when it skipped through one layer into another one, so that indicates that the organic material is deposited on that layer. The ones you see in yellow here were designated as buried horizons in the field and actually found an uptick in organic material, proving our designation in the field. And then we had one that didn't quite meet it. So it's not perfect. Field analysis is just a rough, quick estimation to kind of get you in the ballpark of what it is you're looking for. And then you go into lab analysis to get a better idea of what it is. Here is the results of the hydrometer test. This area has on both sides of it, and these are both sites from either side of the railroad track to compare exactly each side of whether the disturbances have become greater or less. So on the northeast side of the railroad tracks here, we find a very high silt content as well as on the other side. This indicates an area that has a pretty standard routine flooding that would wash away and truncate the clay percentage, or the clay content out, and then it has been stabilized to help with the construction of the houses, indicating that a transition from the parent material, which is the sand, into the clay. Over time, an older soil, as it develops more and more, will actually increase the clay content and decrease the sand and silt. So results of our field and lab analysis is 4 of the 5 buried horizons were correctly identified in the field. There's low sand percentage, high clay, and low silt, indicating a transition from a very unstable floodplain into a more stable one, probably indicative of the housing encroachment. And then through we went with a different carbon-14 sampling agency this time. Went with Beta Analytic, other than direct AMS we've used in the past. And with Beta Analytic, they have much different sampling process. And we sent several samples off and resubmitted samples. And we only got really 2 solid dates of 11,160 BP and 8,960 BP, indicating of that Paleo-Indian age that they are looking at. So carbon-14 samples that we took from charcoal or burned tree particles, we excavated from inside the actual channel itself, the creek channel. So the discussion of this would be, from this research, would be, will the buried horizons yield any archaeological importance? It's really hard to tell. They weren't very thick, so it's not a very long period of time. The low clay percentage, again, is indicative of a transitional soil, transitioning from the parent material into an older developed soil, indicating more stability, or increased stability from past environments. And then the railroad construction itself, further research is definitely required to investigate to see how much that disturbance actually disturbed the area itself, because the railroad track actually runs over the site. So the buried horizons present a higher % chance of archaeological importance. The soils close to the channel have been truncated due to flooding events. The ideal sites would be away from the channel itself. The further away from the current channel and floodplain you go, the older. And also there's a large prairie dog infestation down there. So the further away from that you get, the better and less bioturbated the area will be. And I'll open up to any questions now. Yes.
So you said you found 4 out of the 5 horizons. How did you know that you were looking for 5?
So in the field, to it. So in the field, what we have is this soil here. We have a little B, which is a buried horizon. We have a little B here. So these are soils that we found in the field to be of a darker content or out of order. Here we have a C with a little b, which is a parent material that's been buried, because it also has a buried A underneath it as well. So a dark band was found underneath that. So these areas were seen in the field to have the characteristics of a buried horizon. It's usually in the field, all you can do is look at the color, and if the color is darker, that's one good indication. And then digging into the horizon itself, you can usually find old organic material. If it's relatively young, if it's a lot older, then a lot of that stuff's destroyed. But a thick color band, thick dark band through the profile is usually a good indicator of that. So then we designated that, and then we went into the lab itself and did the organic processing. And then the ones in yellow here are the ones that we found to actually have a large spike, or at least an uptick in organic percentage from the layers above, except for one. One had right around the same or lower. Yes.
In your kind of conclusions, applications, you mentioned that it could be of archaeological importance. What do you mean by that exactly?
So the surface with a buried horizon is, like I said previously, it's a